Hello and welcome everyone. I'm your host Stefan Burns, geologist, geophysicist, space weatherman, here to discuss the crazy energetic conditions that currently are in the Pacific Ocean. We have a whole slew of cyclones rampaging through the Pacific, and we are having some big volcanic eruptions. Today we are having Kilauea's 54th lava fountain episode since December of 2024, which is a record number of lava fountain episodes. And it's also in a time period faster than the prior record, which was about 3 years, from 83 to 86, part of the Pu'u'o'o eruptive cycle. I think it was 46 eruptive episodes across 3 years. We've now had 54 in a little bit more than a year and a half. But other big news is that yesterday we had a gigantic volcanic eruption from Ambae Island in Vanuatu, part of the largest volcano there. Also a shield volcano, very similar to Kilauea. It blasted an ash plume up 15 kilometers. So basically 50,000 feet, well up into the stratosphere. From what I could tell, based on my research and searching, this is the largest known eruption to have struck that volcano in recorded history. And when the Japanese detected it, they detected that there was this big ash plume and everything. It happened at night. So it was on the nighttime side when it first exploded, still going. They were worried that there could be a tsunami coming in. So that shows you how serious that volcanic eruption is. So we have massive volcanic eruptions occurring right now in the Pacific. We also had Titan Ridge, if you remember that. Largest eruption of 2026. We'll give it a look. I don't think it's been that active for the past maybe month or so, but that was a big eruption earlier, just a couple months ago in 2026. Kilauea, of course, now Ambae volcano, Vanuatu, and all these cyclones. So sea surface temperatures are at record highs. Actually, just a few days ago, we had a record for highest global sea surface temperature for our historic records. So this El Nino is getting even crazier than what you may have heard, because a lot of these weather forecasters, they're just looking at weather, like sea surface temperature, and they're just looking at some of these variables. They're not considering volcanic activity, right? If we're seeing this sort of activity from Kilauea, which is one of the world's largest hotspots connected to it, and Ambae volcano, being a shield volcano, also connected to these deep magma sources. Imagine all the deep sea volcanism that we're completely unaware of that's occurring right now, also influencing the temperature and the other factors of the ocean. Now, it's going to be the deep, deep, deep ocean, but there's got to be some effect. We know that CO2 flux from undersea volcanoes is very significant. And while we know that CO2 is a very significant driver of climate being a greenhouse gas, among many others. So that is what we're going to cover in today's video, just how this El Nino is getting even wilder than many people realize. It's going to be tying or exceeding the historic El Ninos that occurred in the 18th and 19th centuries. So, hello, welcome. I'm your host, Stefan Burns. This is the 54th eruptive episode from Kilauea Volcano. We're about 5 hours in, halfway through. And it took about 12 days for it to recharge from its last episode, which is episode 53. Occurred the same day as the total solar eclipse, August 12th. We're 2 days before the partial lunar eclipse. That's on Thursday. Today's Tuesday. That's the 27th. Today's the 25th. So Kilauea erupted a little early, but still fairly close to that lunar phase. And this eruption should last about 10 hours in total. Lava fountains spiked up to 500 feet at their highest, or so, maybe a little bit more than that. But now they're settling out probably about 350 feet, 100 meters. I can, in fact, even go back a little bit to show you these really big lava fountains that started up right when the eruption first got started. What we often see is that the volcano, there's this overflow, and then it really starts to go, and then there's a really big push pretty early on in the beginning, and then it settles out for some time. So we see this really big push here, and this being about 3 hours ago now. So that's when it was really going. I mean, look at this chunk right there. Really big chunks coming down. Huge like volcanic bombs and pumice pieces and more. I mean, look at the weight of this really raining down. Of course, a lot of it's still molten, so it's flowing down the slope there. And look at how this is a new wave now actually going down, right? So this is a big eruptive pulse that really struck, but as we go forward, you can see it kind of died out. Look at these cyclones though, really cool. Little cyclones being generated, heat vortices from the volcano. That's insane. Look how it's going up the slope there and connected into this larger system. Wow, that was wild. So we've been having these as well sweep across the landscape. The caldera is slowly filling in as a result of these eruptions. There's a big collapse of the caldera almost a decade ago now. And so each eruptive episode, a lava fountain episode, has been slowly filling it in. Eventually it'll probably sink down again. Depends on the magma chambers and how full they are, because if you have full magma chambers, you're not going to get a big collapse. But if that lava, let's say, evacuates the East Rift Zone for Kilauea, then you could have a problem. And well, that's what happened back in 2018. So let me show you that data, and we'll look at our tilt data really quick. Here it is. So here's our tilt data for Kilauea, and let me actually refresh this here so we can make sure it's the absolute latest data, because you have to manually refresh this if you want to be really, really precise. But we see our tilt is going down, down. Here we are, so we're about halfway through, as you can see at this moment. Here's the past year of eruptions. See how we've been getting them closer and closer in time. We have these really big eruptions here. Now we're in a new eruptive phase, clearly. It looks like there's been actually 3 pulses of unique magma composition that hit Kilauea during these 54 episodes now. So maybe we'll see a new one start again. Here's our East Rift Zone, which if we go to the bottom here, you notice that we had this uptick after the magnitude 5.2 earthquake that struck the seamount that's part of the Hawaiian volcanic system off the coast back on, I believe, the like the 11th of August. It was right before episode 53. That's a Kamaehuakana-Loa seamount. And so we noticed this uptick at the East Rift Zone, which is concerning because that's where we had 700 plus homes destroyed in 2018. Also big earthquake activity. And you notice that it's a notable uptick on this long downtrend, though there's a lot to go if it's going to reinflate, okay? But we see that with this eruptive episode, we did get this inflation there, and now this big drop. So it's kind of interesting, almost looking like a pulse of magma traveled through that rift zone and then reached Kilauea and really got her going. Because we see this is at 6 a.m., this pulse. If we go to our day data right here, we see that this is 6 a.m. So right before she started to go down, we had that pulse at the East Rift Zone, and now they're both declining in tilt. So let's look at this volcanic eruption that's been occurring at Ambae Volcano. I hope I'm pronouncing that right. This is in the Philippines. Maybe you saw all these cyclones here. We'll talk about these cyclones swirling through the Pacific. Classic sign of El Nino. You get cyclone activity switch from the Atlantic to the Pacific. So hurricanes, typhoons, all the above. We can go here to find Vanuatu. And here is our volcano, okay, right there. Now, it's going to be kind of difficult to see with this, so let me show you the USGS map. Here's USGS, here's this volcano. You can actually zoom in and see that the main caldera has this lake around it. So that can make it pretty explosive because that water can get in there and really make it explosive. We saw big eruptions from this back in March, okay? But not as big as what we saw yesterday, and it's continuing on now. So if I go back, here we see the eruption that sent that ash cloud up beyond the stratosphere, which is why this shows up so nice, because we're seeing the normal tropospheric weather. This punched through and reached 15 kilometers up, which is why even at night it shows up very bright and reflective. Dissipated out, then the sun rises, and as the sun rises here, right, we'll go forward 10 minutes at a time now, we see all this ash being emitted from the volcano. And go forward, there it is, still smoking, still going nuts. So this eruption basically has just started. Maybe it's just a one-off, but this again is the largest in history as far as I can tell with the data I could find. This is Vanuatu's largest active shield volcano. We can see some photos here, thanks to John. So really interesting. They evacuated the entire island back in 2017, 2018. And the eruptions then sent ash clouds up about 10 to 12 kilometers. This is bigger. So they evacuated 11,000 residents back then because of these major eruptions in 2017, 2018. And no one, as far as I know, has really gone back. There was acid rain, crops are destroyed, a lot of problems, significant SO2 emissions, and there's older activity than that, 2005, 2006, similar major phase with ash plumes going to 10 to 12 kilometers. Again, acid rain, ashfall, etc. 1995, there's some eruptive activity that was notable, but not as much of an impact as 2005 and 2017. Then you had activity back in 1870, 1880, and that's, I mean, it's probably going to be more than that, but basically that's what we know. So this eruption that struck yesterday, August 24, 2026, is the largest in recorded history from what I can tell with my searching. So take that for what it's worth. But if we go back here, we see that, okay, well, we have Kilauea erupting like crazy. We have this volcano erupting like crazy in the Pacific, right? Hawaii just got hit by Hurricane Lala, which is still out there. Here's Hawaiian Islands here, of course, right? Well, here's Hurricane Lala, still zooming around now in the north. A very nice cyclone, as you can see there, with that rotation and that anti-clockwise rotation. And well, we see tons of other tropical storms, disturbances, and more. So we have Tropical Storm Mizelle there off the coast of Baja, eating up some of these other remnant lows and tropical storms. So Julio and Isel are having some fun together. Disturbance areas over here. This is where the seawater is very, very warm. Tons of disturbance areas over here around Guam. Here is tropical depression Atsani sweeping through the Philippine Sea. And look at this. Here we have a typhoon, Sadul, which was a very strong typhoon just a day ago. It's going to be slamming into China in the next few days. Yeah, so right now it's just passed over the southern islands of Japan. It'll be slamming into China. Forecast is for Thursday. But this amount of cyclone activity in the Pacific is like a trademark characteristic of El Nino. And with a super El Nino where the sea surface temperatures are so high, we can expect this to get even crazier, because right now it's the end of August. It's August 25th. Well, think October, think November. That's when things really have the potential to be nuts, and we're building. And these volcanic eruptions, right? Think of the gas emissions and how that's affecting the weather of this area, how that's affecting the atmosphere composition, and ash has electrical properties to it, right? Generates electrostatic charges. So we have a potential for these volcanic eruptions to really supercharge things even more. But if there are sufficient SO2, sulfur dioxide emissions, maybe that later on cools things off. It's hard to say, but the ash is very electrically active. And while cyclones are all electrical, right? You have these plasma electric currents which exist in cyclones that actually alter the magnetic field in their own location by about 0.3 nanotesla, maybe even up to like 0.5, 1 nanotesla. You can measure it. It's measurable. It's been done before. Not really seeing too much in the Atlantic. So that is another characteristic of El Nino, where you have just less hurricane cyclone activity in the Atlantic. Two areas there where they're tracking, but in general, nothing super, super, super crazy. But this is pretty wild, actually. These three basically vortices stacked on top of one another. So they're not really becoming anything, but this almost looks like a dragon, if you ask me. But this triple vortex stacking right there, slamming into Western Europe. And there's been tornado touchdown in France. That was like EF2, EF3. Hundreds of thousands of lightning strikes have swept across Eastern Europe over the past, Western Europe over the past few days. So there's been tremendous activations of the local electric field, the Schumann resonances, and more. So this really is shaping up to be a powerful El Nino. And we can see our sea surface temperature anomaly here. So this is some data from Cyclone WX. This is our sea subsurface temperature anomaly. This is the trademark hallmark characteristic of El Nino, is that you have this isotherm at depth where the temperatures are greatly above normal. And we are seeing now temperatures are starting to cool off here below normal in this strip, but that is normal to see for an El Nino, to see this disparity between them. But if we go up here, we see our sea surface temperature graph. And not only do we have strong high sea surface temperatures here, also off the coast of Baja, where we're getting a lot of cyclones to form. And of course, all around Japan, the Korean Peninsula, China, going up to Kamchatka. This whole area is also supercharged with very warm water, therefore a lot of humidity, high temperature heat waves, and more. So this is a very dynamic time period. Then look at the Mediterranean. Mediterranean is super hot right now. The Atlantic's pretty warm, right? Basically, most of this is looking very, very hot, other than the Arctic Ocean up there. So the sea surface temperature anomaly keeps rising. They have ways to kind of chart this out. They have these anomaly plumes here. And what we're seeing is that basically the different model runs are showing that this El Nino is going to peak probably over 3.5 or even perhaps beyond 4 Celsius, which is really simply ridiculous. If you track this stuff, this is absolutely crazy. So again, this could end up being the strongest El Nino in the historic record. Here we see our top 9 El Nino events since 1870. Okay, so there was a big one that occurred back late of the 18th century, like 1778 to 83, that time period. Well, so we don't have that one in there because we have less rigorous data for it, but we have the strongest 9 El Nino events going all the way back to 1870. At least for this time period right now, we're more consistently staying elevated for a long time. Now you see here, it's kind of, this is the 1878 one. It's choppy, probably because the data quality is just not as great, further back in time. But if you were to draw a trend line through that, it's going to be lower than where we are now. Now this most recent 2015 and 2016 El Nino was pretty strong, but we are higher up than that. Notice how it peaks there in October, November, December, January, and then eventually next year we should be out of it. But some of these historic El Ninos, they go on for actually a few years. Like there's these pulses and rhythms to it. It's often not just a one-year event. So that's something to be mindful of too. There's a connection in time with these super El Ninos to drought, to famine, wildfires, all the things that you basically don't want. So that is not good. And this is what we're seeing right now with basically this El Nino being really, really wild. Here's a post I wanted to show you. Basically, another global ocean temperature record has been hit. If we look at this data graphic specifically, and this is for the 1996 to 2025 normal range, okay? But what I'm really pointing out here, less so than this being like an all-time record being broken, more so is the fact that typically you have the highest temperature spike here, and then you kind of go down, and then you go down again. This is the global value, okay? Well, look at how we're having this spike now out of phase with that normal rhythm. Now it's peaking later into the summer. So this is showing that there's been a clear phase shift, a really big shift with our climate system as a result of a lot of factors. This El Nino, this super El Nino is just a symptom of that, really. We're going to have El Ninos, La Ninas. It's just a normal rhythm back and forth that occurs. But how strong they are is a sign of where we're going, basically. That's a very clear phase shift. A little concerning if you ask me. So I'm not exactly sure what to think of that, but yeah, pretty crazy stuff. We see, as I mentioned, the video I released earlier today, the quick update, 5 M-class solar flares have blasted off. We are now cooling off from that 6.9 M-class flare. These charge the ionosphere with more plasma, stronger plasma convection in the ionosphere, driving electric currents at depth in the oceans, in the crust of the Earth. This also affects tropospheric weather. We see that we've had quite a lot of solar flare activity over the past 7 days. Really, the 20th of August and the 25th of August are the key days for that, and we could have more. We do have a solar storm inbound. So we have a solar storm already inbound, as we can see here. And there's actually 2 solar storms inbound. This is just showing one of them, another one followed up behind it. So this is looking like we're gonna have impact on the 28th of August or so. NOAA has issued a G1 geomagnetic storm forecast for the 27th. That's minor storming. They've issued a G2 level forecast for the 28th. That's a more moderate storming. So we're right now in the midst of it. And well, the big thing is that we're having all the cyclone activity, heat waves, and wildfires and more. We have a big heat wave right now hitting Southern California. I'm in it right now. It's the thing to note with these heat waves, the thing to really note these heat waves is that if you have the temperature go up, okay, sure. But if you have a lot of humidity, it's harder to push that temperature higher. So right now, some of the highest humidity for the entire United States is actually in this region here. Yet we're having a heat wave come through. So typically that humidity would keep things relatively cooler, simply because it takes more energy to heat up the water in the air. So if you are able to have a heat wave with the humidity, that really tells you something as to just how much energy is in the system, and the fact that, yeah, we're not radiating it all out. We have a radiation imbalance. Earth radiates out infrared, but it's also taking in a lot of energy from the sun. That's the main energy driver. But we're altering that balance. And also think of all the fossil fuels that have been sequestered for millions of years, which are lighting with a match, exothermic reaction, heat is generated, in addition to greenhouse gases, carbon dioxide, water being the main ones, water really being the main one, that hold that heat in, therefore further influencing the effect of capturing solar energy from the sun, which you can't turn off the sun, right? There's some billionaires, they're stupid, that want to spray, like certain aluminum compounds into the atmosphere to reflect away sunlight. A lot of people think they're already doing that. Regardless of what you think, it's all bad ideas. It's all very, very bad ideas. So this is where we are right now. And well, Kilauea is not going to stop erupting, and the other volcanoes aren't going to stop erupting. Maybe that's actually what saves the day, is we get a big volcanic eruption that we may not want one, and maybe it causes some problems, but that could actually cool the Earth down. You could get 2 degrees of cooling with a really big VEI6, let's say. Maybe you get 2 or 3 of them pop off. They often cluster in time. Look at the Bronze Age collapse, earthquakes, volcanoes, drought, famine, and then as a result of all those factors, you had people then migrate and leave and look for better opportunities elsewhere, and that's the creation of the Sea Peoples, if you know the history. So Kilauea is erupting. The 54th episode, record-breaking. She'll probably be back in about 2 weeks. I'll be back before then, giving you all the updates that you need as it relates to what's happening here on Earth energetically with earthquakes, volcanoes, severe weather, geomagnetic storming. We also examine what's happening with the sun, solar activity, space weather, planetary resonances, and alignments, interstellar cosmic forces, consciousness, and more. Yes, that's a lot, but we covered it all here. Happy to have you all here. Thank you all so much for joining the channel, subscribing. I release videos almost daily, so if you want to stay up to date, then please subscribe, click that notification bell, and I'll see you all in the next video.